That's really good.
Oh, wait, are we going over problems right now? Start with the one.
Yeah, you might as well just do all of them.
So, I probably should tell you that my blood pressure spiked when I was grading your tests. Especially when we got to limits. You seem to be very creative. Invented a lot of new math. Okay, so I think what I'm going to do is, regardless of how many problems we're going to go over today, I'm probably going to scan this and put it on the website anyway, to actually have access to the solutions later on. But which ones would you like me to do?
All the hard ones.
I just have a good question. Do you know the average?
Yes. 92 out of 150. You do realize that 92 out of 150 is 61%, right?
Yeah.
Okay. Because 90 sounds like a large number, but in reality it's only 60%. Okay. So which one? Number one?
Yep.
Okay, so I don't really necessarily know why this was such a hard problem, because it really seemed like I couldn't have picked a harder problem, when in reality I actually made it very simple. I even wrote it as cosine of x plus a half, not like 2 cosine of x plus 1 or some other combination. It's a fraction. What's the number one rule about fractions? Were you looking for the domains? You can't have 0 in the denominator, right? So the idea is cosine of x plus 1/2 has to be solved for 0, right? Which means cosine of x has to equal minus 1/2. For what values of x is cosine of x minus 1/2? 2 pi over 3 and 4 pi over 3. Since cosine is negative in the second and third quadrant, and cosine of pi over 3 is 1/2, then it only makes sense that you're looking at 2 pi over 3 and 4 pi over 3. And so the answer would be all real numbers except for 2 pi over 3 plus 2k pi and 4 pi over 3 plus 2k pi. But I would have just settled if you actually could come up with 2 pi over 3 and 4 pi over 3, which seemed to be a very challenging idea. I don't know, it seems like the most popular answer, which is one of the reasons why I don't understand why. One of the popular answers was, well, cosine of x is trigonometric, is defined everywhere, so the domain is real, all real numbers. Well, it is all real numbers for cosine of x, but you have 1 over cosine of x. So the key idea is, your problem is that you can't divide by 0. Does that make sense? Okay. What else? I don't know if you noticed, but in proportion of like 90% of your test was out of your homework or the practice problems that I gave you. So, number 2. It seemed that the most popular answer, which I guess was nice, because the most popular answer was all real numbers except for -1. So that was close enough to the answer. But anyway, that seemed to be the most popular answer, so I actually gave you 12 out of 15 if you wrote that, even though, you forgot to actually account for 0.
Why?
Why 0?
Yeah.
Well, what are you actually solving for? G of f of x is equal to x plus 1 over x plus 1 divided by x plus 1 over x plus 2. In order to be able to talk about 1 over x, what has to happen, what values can x not take? 0, right? Moreover, you simplify this by multiplying and dividing by x. Again, if you multiply by 0 over 0, that makes absolutely no sense, so you have to make sure that 0 is not part of your domain. Does that make sense? And we did this precise exact problem. I know it's been like 5 weeks ago, but nonetheless, we did exactly this particular problem, and I spent about half an hour discussing about, exactly about that particular issue. Okay, what else? Yes?
4B.
Yeah, 4A apparently was more or less a success, and I was the only one that was a success. I actually wrote down the, out of curiosity, I guess I left it in my office, but out of curiosity I wrote down the number of points that every single person in the class, bless you, scored on number 4, and the vast majority of the class scored anywhere between 20 and 30. And that was 60 points. There were a couple of 40s, and I guess, I don't know if there's any 50s. I don't think there's any 50s. I don't remember, but I don't think so. Okay, so 4B. When I was grading these particular limits, I made a very big note to myself that whenever I'm going to teach Calc 1 from now on, I will never ever in my entire life give students cheat sheets, cheat ways of going around systems, as in the sense of, well, the degrees, the powers are the same, so they must be the ratio of the coefficients, which was something that was very popular. Now, I don't know how many times I actually spent talking about that particular thing, saying that that only works if it's actually a rational function. And what we define a rational function is a polynomial divided by a polynomial, not a trigonometric divided by a polynomial, not any other combination whatsoever. Now, what really made me yell and scream to myself was the fact that a vast majority of class decided that sine squared of 3x can equal either 3 times sine squared of x, or can equal x times sine squared of x, or of 3, or I even saw, I think, 3x times sine squared.
There's no sine of 3x squared.
Oh yeah, that was also another one. I forgot about that. Sine of 3x squared. At which point the my elbow kind of had this reaction of just crossing everything out in just one swoop move. Do you understand why none of that actually happens? Sine is an actual function. 3x is the argument of the function. Okay? You can't just take numbers out as you please. It doesn't work that way. Okay? Moreover, sine squared of 3x is sine of 3x quantity squared. That's how we define powers of trigonometric functions. Now the key idea is 3x is the argument of sine. not just part of it, not any of it, or anything like that. If you just write sine, that means absolutely nothing. Okay? It's the equivalent of saying square root. Does that make sense? You can't just be talking about that. Or parentheses squared. Well, literally, it's exactly the same thing. I mean, sine is an actual function. Whatever the argument is, that gets applied to the argument. Okay? So, you can't just basically look at the power, or just the x and just, do anything else you want with it. On the other hand, so, on one hand, I was very disappointed to see the fact that one popular answer was, well, sine is squared, x is squared on the bottom, so the answer must be 3, or 9, for that matter, because it's equal powers. On the other hand, another very, very popular answer was the fact that the limit, as x goes to infinity, of sine squared of 3x over x squared is equal to the limit as x goes to infinity of sine of 3x over x, quantity squared. So it must be the limit x goes to infinity of 3 times sine of 3x over 3x quantity squared. Well, this goes to 1, so it must be 9. That was very popular.
I don't remember learning that.
Because it's not right.
I know.
The limit as x goes to 0 of sine of x over x is equal to 1. Okay? So, that being said, how are you supposed to solve this problem? And the thing that was actually, I guess to some extent, a little more frustrating was the fact that I actually did a problem like this, write the review right before, the test. Point is, it goes to infinity, sine is a trigonometric function, is bounded, x squared goes to infinity, which means the whole thing goes to 0. And we called this the squeeze theorem. The idea is, as 0 is less than or equal to sine squared of 3x is less than or equal to 1. And so 0 over x squared is less than or equal to sine squared of 3x over x squared. It's less than or equal to 1 over x squared. Well, this is clearly 0. That goes to 0, which forces the middle one to also go to 0. Does that make sense? Yes.
Oh, it can. Alright. Just sine, not sine squared. Can any value be between -1 and 1? Is that the parameters of just sine by
Yes.
itself? Alright.
Sine of whatever.
It has to be between -1 and 1.
Yes, just think about the graph. Sine and cosine are bounded functions between -1 and 1. It doesn't matter what the argument is. Questions?
We're moving on. Next problem.
Sure. Next problem. I got a lot of does not exist. Because 1 divided by 0 can't exist, so that does not exist. No. Remember, 1 over 0 is infinity. That's basically what we talked about. We don't know if it's plus or minus infinity, but nonetheless it's infinity. And so the idea is that when you look at, and this is actually a problem from your homework. Actually, both of these were problems. Actually, all 3 of them were no. Correction. All 4 of them were problems from your homework. The limit as x goes to 0 of 1 over x minus 1 over x squared plus x. Now, what I would be curious to find out, by the way, is How many of you actually got this problem right on homework? Not on the test, on the homework.
Not without help, though.
Not without help.
Math lab.
Okay? You have to be careful. I mean, the one thing I should probably say, and I probably should have said this to begin with, as much as the math labs, the math learning center is a very nice tool to use, you have to know how to use it. You can't just go there and say, I don't know how to do this problem, can you do it for me? It doesn't necessarily help you in any shape or form. They're going to write it out, you're going to copy it, you're going to go home and still not know how to do it. So the whole point of it is that's supposed to be going there and actually asking why that's the case. Can you explain to me what makes you think that you need to do that? What's the point behind this problem? And not just, because in the end, homework is worth 15% of your grade. Yes, it's 15%, which is a good chunk of your grade, but that's spread out throughout the semester. There's only there's 12 homework sets that you're actually looking at, so it's not like it's really the fact that you really have to get those points perfect should be your main priority. The whole point of giving homework is for you to actually understand the problems better, not let me copy it from somebody else, or let me go and basically get help in the sense of this is one of the reasons why I on purpose put even problems on the homework and not odds, because I don't want you to just copy them from the solution manual, or and so you need to basically make sure that you understand the problems. Okay? Alright, now coming back to this. This, as it turns out, is actually a very simple problem. All you have to do is actually get to a least common denominator. So if you are to get to a least common denominator, we can notice that this is the limit as x goes to 0 of 1 over x minus 1 over x times x plus 1, which equals the limit as x goes to 0 of x plus 1 minus 1 divided by x times x plus 1, which equals the limit as x goes to 0 of 1 over x plus 1, which is 1 over 0 plus 1, which equals 1. Well, again, the key idea is, and we're going to come back to this a little later on, as soon as we're going to do more derivatives, we're going to come back and actually talk a lot more about limits, okay? This is not the last time you actually see limits. And I know you're all very excited about that. And so the idea is, this is what I talked about when we looked at problems like this. If you put in 0 for x, you end up with infinity, minus infinity. Okay? I don't necessarily know which signs and what not, and I don't necessarily care about that much. The idea is it's infinity minus infinity, which is called an undefined form. We don't know which of the two infinities win. If the first one wins, then you might end up with plus infinity. If the second one wins, you might end up with minus infinity. As you can see, based on the answer, as it turns out, they actually both go to infinity pretty much at the same rate. Okay? Does that make sense? So because it's infinity minus infinity, there's something that you actually need to do as far as work is concerned. Okay? Chances are you're not going to have a problem. There's really no point in me putting on a test a problem that you just basically plug in a couple of numbers and say, oh yeah, it doesn't exist, and move on. Okay? That really is not testing you on anything. Okay? And so the idea is you have infinity minus infinity, there is work to be done. Okay? Does that make sense? Okay. Questions about this? Okay, so moving on. Part D. I gave you 5 out of 15 if the limit and if you actually said the limit was 2, even though I should have not, but I figured by that point, considering the previous two problems were the majority of tests were just zeros, I figured I should probably give you something. That's probably how you come up with 20 sometimes. 15 for the first one, because that was pretty much everybody more or less got it. What should we observe? What is the definition of the absolute value of x plus 6. Remember, I came here the first day of class and we started looking at review, and the first thing that I put on the board, one of the first things, was the absolute value of x, the actual definition. And I said you'd better remember this because it'll come back a gazillion times throughout the semester. What is the definition of the absolute value of x plus 6? It's x plus 6 if x is bigger than or equal to negative 6, and it is negative. I'm writing it in a wrong way because I've seen this on some of your tests. It is not negative x plus 6, it's negative quantity x plus 6. Is everybody understanding why? The quantity as a whole becomes negative when you go less than negative 6. So the quantity as a whole has to be changed to sign to make it positive. Are we understanding this? Okay. So, that being said, when you look at the limit as x goes to minus 6, in reality what we're looking at is the limit going from the left and the limit coming from the right. Coming from the left, the absolute value of x plus 6 is going to be, so you're going to have 2x plus 12 divided by minus the quantity x plus 6. And if you factor out a 2 on the top, here, let me just do that. So if I factor out a 2, I have 2 times x plus 6. This ends up being negative 2. And if you come from the right, you have 2 times x plus 6. Divided by x plus 6, and that becomes 2. Which means your limit does not exist because your two ends don't agree with each other. Okay? What else? For number 5, if you didn't use the definition, you got 0, as I more or less warned you at the, before the test started. If you use the definition, one popular way of applying the definition was that you forgot to actually put in 0 for h. So you worked out all the way to the end, but then you actually forgot that the definition of a derivative actually starts with the limit as h goes to 0 of the fraction. So that was one part, and I guess I don't remember what I did for that. Bless you. Is there any point in going over it? Okay. Number 6. I want to talk a little bit about 6b. I warned you, and not warned you in a negative way, but I advised you to use parentheses. I advised you that parentheses are really your friend as far as especially differentiation is concerned. One very popular answer was the fact that f of x equals x cubed plus x divided by x to the fourth minus 2. So when you look at the f prime, is 3x squared plus 1 times x to the fourth minus 2 minus 4x cubed times x cubed plus x. I've seen this answer on a couple of exams. By not using parentheses here, you ended up actually multiplying 1 by x to the fourth minus 1 and not actually distribute the 3x squared as well. This is what I was telling you. Your parentheses are really your friends, and you should use them as much as possible, especially when you're dealing with like complicated expressions, because otherwise you're going to lose track of what gets to be multiplied by what and everything else. Okay? And at this point, it might not necessarily be that dramatic because, you know, if you forgot the parentheses, I took off some points, but not necessarily a lot. But as we're going to move forward, bless you, as I told you, one of the things we're going to do is actually graph functions. And one of the functions we're going to be graphing a lot are actually rational functions. You're going to be asked to find the first and the second derivative. Okay? And you're actually supposed to figure out where that first and second derivatives are zero, what their signs are, and, you know, a lot of work on the first and the second derivative. If you get it right off the bat, then pretty much your entire problem is going to be wrong. Okay? Alright, what else?
E.
Sorry?
No, 7.
7? F of x equals 1 plus x times cosine of x. So, a good portion of you got this right. But, the first thing you look at it, you're asked to find a derivative. What is the first observation you should make when you look at this? Yes?
You can distribute the cosine for the 1 plus x.
You can distribute the cosine, yes. But, even if you distribute it or not, so I can distribute it if you want, but that's not actually what I was looking for. The one thing you should observe is that in either of this form or in this form, you're looking at a product of two functions. Product of two functions. When you take derivatives, you have to use the product rule. The derivative of the first times the second plus derivative of the second times the first. It doesn't matter in which method you're applying it, you still have to apply the product rule. You're not going to be able to get around it. So you're going to have cosine of x minus 1 plus x times sine of x. Now, some of you got to this point, but then for some reason, sine of 0 is 1 and cosine of 0 is 0. Which is exactly not the case, it's exactly the opposite. This is 1 minus 1 plus 0 times 0. So the whole thing is just equal to 1. Okay? I forgot, I probably want to come back to 6c. So the equation was just y minus 1 equals 1 times x minus 0. Now, 6c. And what I'm really focusing on is sine of x over x squared. So when you take the derivative, you end up with 2x times, you end up with cosine of x times x squared minus 2x times sine of x over x to the fourth. What this is not equal to is cosine of x cubed. Minus, I even saw 2 sine of x squared over x to the fourth. Do you understand why that's not the case? If you don't, parentheses are your friends. The derivative of the first is cosine of x. I'll just write it as a parenthesis. Times x squared. Cosine of x is a function. X squared cannot just go in it just because it looks prettier. The fact that I say simplify as much as possible doesn't mean you have to really be starting to be creative and come up with, you know, new mathematical ideas. Okay? Sometimes you can't simplify anything else. I mean, the only thing you can simplify here if you want is you can actually take an x out. You can factor out an x from here, simplify with this, you end up with x times cosine of x minus 2 sine of x over x cubed. That's pretty much as far as you can go. Also, another popular reason for some reason was the fact that you decided that the first terms need to be also put on the, on top of the fraction, even though they weren't originally. Okay. Questions? I actually computed your grades up to this point, and as I told you, I told you in the beginning of the class of the semester, one of the reasons why I use points is because you can actually compute your own grade at any given point, and so you should be able to compute your own grade. Do you know how to do that?
Yes.
You add all the number of points you have so far, divide them by the total number of points you could have had, and that will be your grade. Does that make sense? So far, you have been returned 4 homeworks: the test, the quiz, and the pretest. Well, I guess I never returned the pretest, but anyway, you saw your grades for the pretest, right? So at this point, that basically accounts to 310 total points. Which means we're basically, give or take 20 points, we're basically a third of the grade in. Okay? We're still looking at two extra tests plus the final. The final is cumulative. So do not assume that if you actually did bad on this test, you're going to be, pulling it out and take the next test and, everything's going to be good, and not necessarily review what you actually did wrong here, because it'll come back. It'll come back quite a lot. So, see where you're at and basically make sure that you're on top of what you need to do to make sure that you have a chance of passing the course. Okay. Any additional questions? Do you have any questions from Friday? I don't know if I actually told you. I don't think I did. And I don't know if anybody actually figured out or not. Your test was out of 160 points.
60.
I did still tell you that, right? No? The test was out of 150, but if you actually add all the points up in your test, you'll find out that it actually was added up to 160, which basically means that you had 6.666666% extra.
That's awesome.
Well, think about the fact that the average was 61% with the additional 6% built in, or 7% almost built in. Okay? So that was basically my way of trying to help you out and see if if you actually basically mess up one problem, it still won't actually really mess you up. Yes.
Wait, are you going to post our grades?
No.
Oh, okay, I didn't think so. How many points have we done so far? Did you say 300?
310.
Oh, sweet.
Okay. Alrighty. So, sorry, 36 you said? I got distracted. That's a fun one. Okay, so we're looking at y equals the square root of x plus the square root of x plus the square root of x. So dy over dx is equal to, well, we see a square root, so it'll be 1 over 2 times the square root, x plus the square root of x plus the square root of x, times the derivative of the inside. What would the derivative of the inside be? 1 plus maybe I should color code it. Let me color code it, since I can. You don't have to erase anything, because I'm still going to write exactly the same thing that I just did. So we have the square root of x plus the square root of x plus the square root of x. So now, 1 over 2 times the square root of x plus the square root of x plus the square root of x times, now we have to take the derivative of the inside, that'll be 1 plus 1 over 2 times the square root of x plus the square root of x. Yes?
What inside are you taking?
Sorry?
Like, you have the 1, what part of the inside?
Oh, this is orange, not red. Here, let me...
Like, is it just...
So the idea is the following. First function is the big square root, the black one. So the derivative of a square root is 1 over 2 times the square root times the derivative of what's inside. So now when I take the derivative of what's inside, the derivative of x is 1 plus, now I have to take the derivative of the red. Again, it's a square root. So it'll be 1 over 2 times that square root times whatever's inside that square root. So times the derivative of whatever is inside. What would be the derivative of the inside? 1 plus 1 over 2 times the square root. And it is highly okay if you don't simplify.
Highly okay.
Is this making sense? Okay. What else?
How do we work with theta?
Theta?
Yeah, how do we, like 28, I didn't really know what to do with that. Is that the constant?
No, that's your variable.
Oh, okay.
So it would be like x. Theta in general is considered to be an angle. So whenever you deal with trigonometric functions, theta usually comes into play as a variable. Okay. Anything else? So do we know how to take derivatives? Kind of. Okay. The topic of the day, implicit differentiation. I'm asking if we know how to take derivatives because it'll only get a little more complicated. So, What happens if you have, so the key idea is the following. We know how to take derivatives, right? So if I have a function y equals f of x, so y equals a function of x, then if I ask you what the derivative, what dy over dx is, well, it'll just be f prime of x, right? Take the derivative and be done with it. Now what happens if you actually can't write the function as y equals a function? So for example, what happens if you look at, for instance, x squared plus y squared is equal to 4. Do you know what x squared plus y squared equals 4 represents? A circle, right? So clearly it's not a function, right? It doesn't pass the vertical line test? It doesn't pass either of them, right? So it's not even a one-to-one function. It's not a function, so it can't be one-to-one. Okay, so how do we take derivatives of this? Well, one way of approaching this is to say, well, from here, y squared is equal to 4 minus x squared, and so y is plus or minus the square root of 4 minus x squared, right? Yes? If you are to actually graph it, the top part would be y equals the square root of 4 minus x squared. The bottom part would be y equals minus the square root of 4 minus x squared, right? So I can split it up into two parts, try and take derivatives and so forth. However, this is where implicit differentiation comes into play. We implicitly assume, so we assume y is actually a function of x. So y is y of x. So what happens if I take derivatives in both sides of x squared plus y squared is equal to 4? So what's the derivative of x squared? 2x. What's the derivative of y squared? 2y dy over dx is equal to 0. So from here, dy over dx is going to be negative 2x over 2y, which equals negative x over y.
Why's represented?
What do you mean? Well, no, I'm solving for dy over dx. The goal is to find the derivative. So move 2x to the right side, you end up with 2y dy over dx equals negative 2x. Divide by 2y both sides. Does this make any sense? Yes.
So it doesn't seem like we're keeping the y on the left side of the equal sign. It seems like we're moving the y over to the right.
We're looking for, again, y is not explicit. Y is implicitly a function of x, but it's not explicitly a function of x. Do you understand what I'm saying? It's English. What is the difference between implicit and explicit? We are implicitly, which means explicit means that y cannot be written as a function. It's not written as a function of x. So it's not y equals function of x. Okay? That means that y is not explicitly written as a function of x. It's implicit in the sense that we know, or we're assuming that y is a function of x, even though it's not actually written as a function of x. Okay. So, as it turns out, that's the section. So now let's look at things. How about we look at number 3 on page 125. X cubed plus x squared times y plus 4y squared is equal to 6. So the question is, what is dy over dx? Now you might ask yourselves, if you already haven't, why are we actually interested in dy over dx, even though I can't actually write it as a function of x? Exactly. If you think about a circle, think about that you would like to be able to represent tangent lines and equations of tangent lines at any given point. Okay? And we'll see how that works when we get to them. So now, dy over dx is, so this is when things get a little more messy. So what happens if I take derivatives in terms of x on both sides? So x cubed plus x squared times y plus 4y squared is equal to 6. What do I get on the left hand side? What's the derivative of x cubed? 3x squared. What's the derivative of x squared y?
Why is it wrong today?
Yeah, why did they want us to
Oh, it's a
Product of two functions. X squared is a function. Y is implicitly a function of x. So this is a function of x, that's a function of x. When you take the derivative, you need to apply the product rule. The derivative of the first times the second, plus the derivative of the second times the first.
so the derivative y is dy over dx.
Yes. So far so good?
Okay.
Yes.
So we're technically doing the product here, right? Mm-hmm. Okay, but y's and x's aren't separated when we do the product. They're kind of intermingled, which is why we leave the y.
Y is implicitly y of x. So y is technically a function of x. So x squared is a function of x, y is a function of x. So when I do the product rule, I have to apply, or when I take the derivative, I need to apply the product rule for it. Now what's the derivative of the last term? 8y dy dx. Very good. Equals 0. Does that make sense?
Wait, where'd the 8y come from?
Well, what's the derivative of 4y squared? Well, 4 is a constant. Y squared is going to be 2 times y to the first times the derivative of y. So you have 4 times 2, which is 8, y dy over dx.
So if y doesn't disappear, we still want right dy over dx.
Y can't disappear.
What did the x squared dy over dx? It kind of went away.
Oh, well, because there was no higher power. Think about 4y squared, the derivative of 4y squared, as 4f of x quantity squared. And apply the power rule with the chain rule, or the chain rule with the power rule, or however they call it, because I never remember. This is 4 times 2 f of x times f prime of x. Right? Yes.
Okay, so I'm understanding the product rule. Why do we write dy over dx then? Even though they put
What have I just shown right here?
four times function times the derivative.
What is the derivative of 4 times f of x squared?
8.
Times f prime of x. The chain rule. So what is the derivative of 2x plus 1 quantity cubed?
have 2x plus 1 times 2.
Squared times 2. Right? Where is this 2 coming from? The derivative of 2x plus 1. Right? The derivative of f is f prime. Does that make sense? Okay. Now, are we done with our problem, by the way?
I wish.
What is the problem actually asking of us? Find dy over dx. Have we done that? No. We have an expression involving dy over dx, but we have yet to actually solve for it, right? So if we bring it over down here, we have dy over dx times x squared plus 8y equals minus 3x squared minus 2xy. Right? So far so good? Okay, and so dy over dx is minus 3x squared minus 2xy divided by x squared plus 8y. And now we're done.
Why don't you group those together though? Next to the dy over dx, like the x squared on the other
Well, I'm trying to solve for dy over dx.
side.
So you combine all the terms alike, then you move all the terms not involving dy over dx in the other side. Does that make sense?
So the terms that have the dy over dx.
I have two terms involving dy over dx, right? I need to solve for dy over dx. Right? Think about if I would have 3x plus 2y minus xy plus 5 equals 0. Solve for y. What would you do? Subtract 5, subtract 3x, factor out the y, and then divide by whatever you have. Right? That's exactly what we did. It just, it involves dy over dx. Okay. How about, that should be a good one, 7. So we have x squared, y squared, plus x times sine of y is equal to 4. Again, what we're looking for is dy over dx. By the way, because of the nature of the problems, whenever you're going to find the derivatives, dy over dx is always going to enter as a linear function. What does that mean? That means that you're always going to have dy over dx by its, multiplied by something, but not dy over dx squared or cubed or any other power of it. So it's always going to be, you're always going to end up actually having to solve a linear function for dy over dx. Does that make sense? Okay, so take derivatives both sides. What happens to the left side? What's the derivative of x squared plus x squared times y squared? 2xy squared. Two y dy over dx times x squared. Right? Plus the derivative of x times sine of y. Plus I couldn't hear. X cosine y dy dx equals 0. Does this make sense? Do you understand how implicit differentiation works? Because guess what? The next section, you're going to have to apply the implicit differentiation to word problems.
Okay, so where do you derive y? With the derivative of dy over dx.
And notice what I just told you before, right before I actually worked this problem out. I told you dy over dx will come in as a linear function. Everybody sees this? There's no sign of dy over dx or dy over dx squared or anything like that. So it should be very simple to be able to solve for it because it's just linear. Move all the terms not involving it to one side, factor it out, and then divide by, the factor. Does this make sense?
Yeah. So every time you take the derivative of y, it's going to be back to dx. And you actually get
Okay,
So can I just write directly what the answer is? I'll just do that. dy over dx is equal to minus 2x y squared plus sine of y divided by 2x squared y plus x cosine y. Should be minus.
So in this step, you're kind of solving like a normal equation. You're getting dy over dx on one side,
Yes.
and everything else on the other.
Okay. Let's move on. 11. I was going to move on to something else, but 11 sounds too good to pass out. To pass by. Not pass out. Tangent of x over y is equal to x plus y. So what is the derivative of tangent of x over y? Secant squared of x over y times y minus x dy over dx divided by y squared is equal to 1 plus dy over dx. Well, take separately. What is the derivative of x over y? X is a function of x, y is a function of x. We're looking at the quotient rule. Derivative of x, which is 1, times y, minus the derivative of y times x, divided by y squared. Does this make sense? Okay, now we're trying to solve for dy over dx, right? And it looks like it's very ugly, right? So we should try and make it a little nicer, right? How should we do that? What happens if you multiply by cosine squared of x over y both sides? Times y squared, how about that? Let's make it even better. The left hand side will give you y minus x dy over dx. The right hand side will give you y squared cosine squared of x over y plus y squared cosine squared of x over y dy dx.
Okay.
Yes.
Where did the cosine squared come from?
Secant squared is 1 over cosine squared.
Oh.
Rather than trying to distribute all of this stuff here, I just multiplied by it over there. It doesn't really matter, how you do it in the end. So dy over dx is going to be equal to y minus y squared cosine squared of x over y divided by x plus y squared cosine squared of x over y. Again, remember what I told you. dy over dx comes in linearly, which means you can easily solve for it. Move all the terms not involving it in one side, all the terms involving it in the other side, factor them out and divide by them. Okay? Alright, how about we look at 17. we have x squared plus xy plus y squared is equal to 3. We went almost the whole class period without doing what? Which type of problem we haven't done so far? Equation of a tangent line. So, what is dy over dx? What is the derivative? 2x plus y plus x times dy over dx plus 2 times y times dy over dx is equal to 0. Right? Yes?
Doesn't matter which order you take the dy over dx? So like, could you do the dy over dx over the y?
In what sense? This is the product rule. The derivative of the first times the second, so the derivative of x is 1 times y, plus the derivative of y, which is dy over dx, times x.
Oh, okay.
Okay, now whenever you deal with tangent lines, there's two ways of approaching problems, okay? Approach number 1 would be dy over dx is equal to negative 2x plus y divided by x plus 2y. And so from here, dy over dx at the point 1 and 1. So notice, we don't have y explicitly, but our point is given as x and y. And so, solving for dy over dx, the right-hand side is all known. I can put in whatever values I need for x, whatever values I need for y, and I'll come up with my slope. So it'll be 2 plus 1 over 1 plus 2, which ends up being equal to 1. Negative, yes, thank you. Does this make sense? Yes? Okay, now as it turns out, this particular problem is not necessarily very ugly. But remember this problem. dy over dx was quite ugly to get to, right? If you're looking at an equation of a tangent line, what you can do is you can actually cheat. And say method number 2, from here, plug in 1, 1. I'll end up with 2 plus 1 plus dy over dx plus 2 dy over dx is equal to 0.
Okay. So when we get dy dx by itself, we end up, we divide everything over, subtract and divide everything over. Then we have dy over dx plus dy over dx. It's not changed at all.
Where?
You say you move everything over to the right side, you end up with...
You mean like this?
No, I'm just talking about the left side of the equation.
Okay.
The left
Okay.
side, dy over dx plus dy over dx.
That's 2 dy over dx.
But we never end up with that. It's always just dy over dx.
Why would you end up with 2 of them?
Because there's not one dy over dx, there's 2. So if you move everything over to...
X plus 2y are the factors of dy over dx. This is dy over dx multiplied by x plus 2y. That would be your 1 plus 1. And we're dividing by it, so we're getting it by itself. Notice in this instance, I have 3 plus 3 dy over dx is equal to 0. which means dy over dx is equal to -1. Do you see the difference between method 1 and method 2?
It's only when they give us points.
Yeah, it's only when you actually are trying to find the equation of the slope of the tangent line, basically. Because you're not necessarily asked for the derivative, you can just plug in the numbers beforehand, so you don't have to have these, complicated algebraic operations. Okay? So as an answer, y minus 1 is equal to -1 times x minus 1. Okay, you have a couple more to do as far as equations of tangent line are concerned, and actually 19 through 22, which means you're going to have to do 20 and 22. They actually even give you a picture of what you're looking at. Now 23 through 26, you're actually asked to find the second derivative. So you're actually asked to find y double prime. Would you know how to do that? Are you sure? So if I look at 23, I have 9x squared plus y squared is equal to 9. I'm supposed to find dy, here I'll use their notation, I'm supposed to find y double prime. So you have 18x plus 2y dy over dx is equal to 0. Right? How do you get the second derivative? What happens if I take the derivative over here? Again, what do I end up with? What's the derivative of 18x? 18 plus, what is the derivative of 2y dy over dx? 2 times dy over dx times dy over dx plus 2y d squared y over dx squared. Based on some of your looks, I would assume good thing I started doing it. Does this make sense? Now what is our answer? Our answer needs to involve only x's and y's. Okay? From the above equation here, you can determine that dy over dx is equal to minus 18x over 2y. Right? You can take that in and put it in wherever you see dy over dx. You could also technically take the derivative here. But notice that this is a quotient, so you need to apply the quotient rule if you are to do that here.
Can you do that instead?
Can I do that instead? Sure. So d squared y over dx squared is equal to minus, notice that this is minus 9x over y, so I don't have to carry all the constants. So we end up with minus 9y minus 9x dy over dx, all divided by y squared, which equals minus 9y minus or plus 81x squared over y divided by y squared.
How do you get d squared y dx squared?
That's just the notation for y double prime.
That's just the notation. Okay.
That's the Leibniz notation. This is the equivalent to saying y double prime. Okay? Alright. Everybody has the homework. It's also on the website. Homework sheet, tests.